from zeros and ones. Okay, we can combine all the numbers and zeros and stuff like that, and then whenever there's a number, mathematics you can use, and we can use mathematical formula, and then we can really create network. This is all about. So we are going to create our neural network like that. Very very interesting. Let me see whether we have been able to download everything. Let's go there. Oh, downloaded. Mount. Okay. Okay, you see this? Mine is downloaded. So you see this is downloaded single pixel. You see this cat and dog picture is there, and you can see the picture also if you click it. Okay, and then everybody should be downloaded. You see this? I didn't have to upload anything. Put it on a this thing and all the dog picture there. There could be hundreds and thousands. You see this? So let's close all those things. Different pictures. Okay, so let's close all these things. Okay, all right. So very good. Now we'll start doing it. Don't worry about it. Now let me show you. So now, and we'll be doing. You'll like this part. So how do neural network work? So basically, what happens is in the neural network, you see this x1, x2, x3. These are some kind of a number, and then you combine with some kind of a arbitrary weight. When you kind of arbitrary weight, so everything is connected with a weight, and then once you weight and then you combine and then you put a mathematical formula, and then you see whether it's yes or no. So you see this row one, study 12 hours, sleep 6 hours, and then whether he is what quiz he's going to take a 70%. This is some kind of a exam score, and then 93% of the exam. And this is a formula as a sigma. So what is happen is, okay, this is a very wait. No, my puppy. No, 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 no. Go to bed. That is busy. Go. Okay, so just a minute. I have to take care of this guy. Just give me 30 seconds. I'll be back. Stay there. Stay there. Stay here. Stay here. Stay here. Don't move. Stay here. Stay here. I'm busy now. Okay, this is your sleepy time, beta. Come on. Sleep. Take. Stay here. Look outside. Look outside. Okay. All right. Okay, I'm back. I don't know. Everybody is with me so far?
Yes,
I
Amit.
don't Okay. So what happened is, so I'm going to show you more picture. You will understand. So, okay, let me show this picture. This is a better one. I'm glad I got this one. Okay, so yeah, you understand. You see this? This is a smiley face. It's some kind of Moses, a smile. But you will see this, it is on the screen. So the screen, you see this particular thing, all the screen has, some kind of, you know, screen, and this is a black and white screen, say. So all those spots, and all those whites, only the places where it's representing this thing, these are like a black. So when it forms on the screen, the black represent this and this, and that's how you did this smiley thing is forming. This is pretty, like this is how the monitor works. Now you see this. Now you created a box and say, okay, that's fine. Let's divide it, and this divide into some kind of a 0 and 1, and then we are just converting into a 0 and 1. You see this? So this pixel now, because of the position of the pixel and what the characteristics of the pixel, this it's now we are converting everything into some kind of a 0 and 1. That's what we need. That's it. Once you convert everything in the 0 and 1, and so this is the input image. Okay, so now, okay. So you see this. So this is a black and white image, and this is a color image. I'll tell you what. So black and white image is like a two-dimensional array. So pixel 1, pixel 2, pixel 3, pixel pro. And so every image has a value, pixel has a value from between 0 and 255. Every pixel, okay. Every pixel has a value of 0, between 0 and 250. So darker the image, darker the pixel, the more the value gets. The pixel is absolutely white, then is 0. And the darkest pixel is the 255. So anything in between. And every image, you know, JPEG image, it's like a 28 by 28 pixel. That's the size. Okay. So basically you have a 748 something 28 that size. Now this is a black and white. Now with that black and white, color pixel has a layer. It's not only black and white, and they call blue, green, and red. Okay. You call blue, green, and red. Yes. BRG, RGB, red, blue, and green. You see the red, blue, and green. This red, blue, and green actually combines in a different way and gives all the color. That means there is no violet color or yellow color. These all those red, blue, and green on the monitor combines in a different shade and makes different color. The basic color is always red, blue, and green. Okay, red, green, and blue, RGB. Okay. uh, so basic, and then you combine this, it might create violet, it might create yellow or whatever. Okay, so understand it. So every pixel has two characteristics. Either it is a black or white, and the darker it is, and the number or the intensity of the pixel represent what kind of a value, whether it's a 0, which is the whitest, and the darkest is 255, and anything in between, like as the shade moves up and down, and the number moves and up and down. This is for the black and white. Pretty simple. The same thing happens, but with the color, now the same, but with the three combination of color. That's what it's called two-dimensional array, and this is called three-dimensional array. So this is called, so if you know array, if you have done mathematics in matrix in the college, then you know what is two-dimensional array and what is three-dimensional array. Okay, this is a little mathematical term, nothing this thing. I wish I had a board to explain everything. So for the timing, you understand everything is pixel. Every pixel has a value from 0 to 255 based on the shade of the pixel or the characteristic of this pixel. And for a black and white, because there is only one color, which is the black or white, there's only two color. So that's a two-dimensional array. But when you add a third color, it becomes a color which is the red, blue, and green, red, green, and blue, what is called RGB, and that it becomes a three-dimensional array. And each dimension represent the same thing, just like a black and white. Anything between 0 and 255, and that's a combination of number. All we are doing as a data scientist is to convert this into some kind of a array. And once we have the array, whoa, we got it. Now we convert it into number. Once you got the number, we have the formula, mathematical formula. Then things really get rich. So this is the basic of everything. So now what happened is, so what I'm saying, convolutional neural network, this is what it is. So it what is the English meaning of convolution? It's like this. It's like a this kind of arrangement, right? This is called convolution. So this is this kind of arrangement. So what will happen is, so you see this one I said. So you see this 0, 0, 0, 0. I got this smiley face, this smiley, this thing emoji, and then I convert into it represent on the screen. And now this I converted into some kind of a two-dimensional array of numbers, and this becomes an array of numbers. You see this? So when I do this, so this is a one layer, and this become a convolutional layer, because now we are not talking about one pixel, because every pixel has a this thing image has a value of 28 by 28 pixel, and so this becomes one layer, this becomes another layer, and that's what is called convolutional neural network. Okay, so you have the image, it becomes a layer, then each layer represents certain patterns of pixels. Each pixel has some kind of a zero and combination, and then we use a rectifier. I'll come to this. It's called ReLU, some kind of a mathematical equation, and then we flatten it, we normalize it, and then we convert into 0 and 1. And if there is a linearity, I'll tell you what it is linearity. We break it, and then we have the layer. So that's about it. Now, so if I show this is very difficult to initially to understand, please, but once you know it, you get it, you understand. So I'm really I tried my best to find the right picture for this. So either input arrays, so input image. Now input image converted into some kind of a 0 and 1 because of the pixel density. You saw that between 0 and 255. If it is a color, you add 3 channel, it's called two-dimensional, you make it this thing. You become then you really convolution like in the say the instrument you play in aquarium, like that it goes expand like that. So that kind of a thing, a pattern you use, nothing but each of this layer is nothing but a combination of 0 and 1, and then from there you pull, it's called convolutional layer. Now what happen is you come here, and this is a very important, I think you'll get it. Now suppose you want to represent this picture. Everybody is with me so far, please, because everybody is so quiet, or sleeping, or it is very difficult. Hello,
Yeah, we are listening, Amit.
everybody left.
No, no, they're
Oh,
still there.
okay. No, because this is absolutely important. If you get this, you will understand the convolutional neural network. So now this picture, with this picture, you see these two pixel represent these two, like I did, and this, and then it makes a smile face. All those white outside, you really don't need them. They're not necessary, isn't it? Isn't it? Because in order to convert this picture into uh, into some kind of a number array, all those outside is nothing but noise, because there's nothing. This is white. So why you need this white background? Nothing. So this is called feature engineering. So what you do is you take each feature of the picture and convert into some kind of a two-dimensional array that will represent 0 and 1. And once you have it, and then what you do it here, so you pull whichever is relevant to you. That's called pulling. Okay. Once you pull whichever is relevant to you, and then you create a pulling layer. That means in the only this one, 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 this two dot, and then one line, and then there's a curved line, at the bottom. So all those are the features which represent the picture. Others you can create artificially, you don't need to represent that. So you pull it. We'll pull the important part of the picture, and then you reduce that to layer. And once you have the pulling layer, then you flatten it. Now this is like an array. Now you flatten it. You just input layer, you just flatten it. Flatten it means you just make one row. That's it. That's it. That's it. This is what convolutional neural network. This is how the whole neural network create. And then once you have it, and then you say this, now this is the fun part. Now you create a many those kind of a layer. You see flatten it. Once the flatten everything, you create an input layer, and then after that, and there is a output layer, is a output value. So all this pattern it runs, and then it converts, and then it becomes another layer, and these are all called node, and these are called layer. So this is the input layer. An input layer represents certain characteristics, and then you create another layer. It's called fully connected layer. They also it connected, and all I'll tell you how it will make sense. or it will carry some kind of a weights, and then finally it give a verdict. So you have a picture here. So it's a picture of a dog. All the dog's picture is converted into some kind of features, and those important features are taken, converted into some kind of two-dimensional and three-dimensional array. Those two-dimensional, three-dimensional array understand that pattern because you are pulling the maximum. So it creates some pattern, and then it once the pattern, so it knows this is the input layer. And then in between you create you just put some weight and in some kind of mathematical formula, and then you create an output layer, and that represent one this thing, and then another output layer, and every layer is connected with some another layer, and in another layer is just like a the neuron. I showed you the picture of the neuron which you found that neuron, okay, picture of a neuron, okay, same as remember that I don't find it here. So this created neural network. So once you create a neural network, you see this, and you this will be very clear to you. Do you see this? Come on. So you see the image picture of a dog. So dog image picture, or the dog image picture, what is the important feature? This is the shape of this ear, the shape of his tongue, and the nose, and the color of the nose, and this, that. And outside this, there's nothing. There's some kind of a green background. That's okay. You don't need that. Okay. So this all those things is converted in some kind of a three-dimensional array because it's a color picture, and those three-dimensional array, the important picture, pixel by pixel, is converted into segmented inventory. We get a convolution layer. You saw this. And then from there, we create a layer. And then we create a mathematical formula called rectified linear unit. I'll come to that. And you create a max pooling. Max pooling means the feature, the feature which the only the feature or the array that represent the maximum characteristics of the picture is taken out, and the rest we don't need it. That's called max pooling. So if you are taking the say this nose, so nose, this particular consists of say probably, I don't know, this is a 1 inch picture, so there could be like a 200 by 200 pixel density. So out of this 200 by 200 pixel density, you see some places it's like a very, very light, some places dark. This is a combination it creates, and it creates shape like the nose. So all those little combination of pixel is taken out, and from there we just see which are the feature it really can, if we can put it, assemble it, give me the outer shape. Okay, and then once now we got the outer shape, which are the picture will give me the inner shape like this, and then which are the picture which is not pixel will not we need it. So we take the maximum value of the pixels which represent this characteristic. That's called backpedaling, putting it in a layer, and then we flattening it, then we combine it, and this is how your this thing works. So is a flattening it, and then once you flattening it and you learn, so you are what are happening is your neural network is learning. What is learning? Basically is learning the pattern, nothing else. Once you show like a 10,000 picture of dog, and it learns that every dog has certain pattern of its maximum pulling, where the pixel is there dark, where the pixel is how the dog ear shapes and all those things. It learns the pattern because it's converted into some kind of a 0 and 1, and then we put it into some kind of mathematical formula, and those mathematical formulas nothing but learning the pattern, because pattern only mathematical formula learns it. Then once everything represent, then it said, oh, this particular pattern, it must be a dog. This particular pattern must be a cat, because all those mathematical formula has seen 2000 patterns resemble to dog, and it already mathematically stored there. So they understood that. That's why you create a neural network and you create eyes for the computer. Makes sense? Is it interesting? Give me your feedback. I don't know. if you guys are following me or it is too hard.
You're getting thumbs ups. It's interesting.
Uh, okay. Uh,
But are you
okay.
planning to continue? It's like 2:30, Amit. How much longer you'll continue?
Yeah, I have to because yeah, it's already 2:30, and if you want to learn it, because it's very important, give me another. It will continue for another 15-20 minutes, probably more.
Okay.
Okay, and then we'll wrap it because these are all hard concepts. I don't know. I shouldn't have because I wanted to really teach him. Want you to learn something, and if you get it, really, you'll get the you will have the solid foundation of deep learning. From here, it will be so interesting. You'll not look back, and probably 6 months from now, all of you will so where I am. So now, so here I am. You see this? So this input layer, conventional layer, pooling layer, flattening layer, and then we put a mathematical formula, and then it becomes a neural network. And that's the way. So this is enough theoretical lecture. Let's have some action. All right. So what we are going to do is here, let's get back to our SageMaker. I think it is already downloaded data shop. Okay. And all of you see this, there's a test set, there's a training set, it has a program which is first CNN. I named it first convolutional neural network, and there's a prediction which So what will does it training? If you click on training, there are dogs picture. There's a duck picture. So the training set will learn all the pattern of all the dogs and cat picture in there, and then will programmatically will will feed that test set. Test set also consists of dog and cat to test whether it really learned it or not. When it learned it, they said, "You learned it. A model is built. We already have the eyes." And then we are going to show some picture, which is here, single prediction. And then so that say, "Hey, computer, now you have the eyes. I'm showing you another picture, or tell me it is a dog or a cat." The computer will tell you. Beautiful, very interesting. You understood? So all of the first CNN, click on here. When you click on here, hold on, it will open a Jupyter notebook. Jupyter notebook is nothing but it's a little bit some kind of a playground for data scientists where they can write the code. You can write the code on Python program, but it's a cell by cell. You write it, you run it. So every line of code, whether it's running properly or not, if it is not running, it will. So it's very easy to use the Jupyter notebook. So it's created a Jupyter notebook, but it wants to create a kernel. Kernel means it wants to create a server on where Jupyter notebook run. But every server has an image. So that's what is called kernel. So what we are saying is, we are saying kernel, we are saying no, don't say data science. We say, we come here and we use image of, let's say, TensorFlow, because this is a TensorFlow. We can use GPU. I can use because I have permission. You guys don't have a permission. So let's use the highest one, TensorFlow 261 CPU optimized. Okay, please make sure, otherwise you don't use anything below that, because below it won't work, because this code is little latest code. You take this, and the kernel is Python 3. Okay, that's it. Python 3. There could be other also. And here it says ML 233 medium is the size of the server instant time. You you can also write automated script. We don't have it. Don't worry about that. So probably I am selecting MLT3. You may or may not have on the free account, but whatever you get it, if you get MLT3, just select it and it create select. So your notebook will start, notebook kernel will start. That means your notebook server will start, your computer, because this has to run on a server, otherwise how you are going to run it. And that is called kernel. The kernel is nothing but a server with the image, the right image. What write image code? We choose a TensorFlow, which is a framework of deep learning. Make sense?
Yes.
All right. So once you have this, it takes about 2-3 minutes to start this thing. Okay. And now it will take 2-3 minutes. Okay. Now I will start explaining it to you what you really we are doing. So there is a something called TensorFlow. TensorFlow, and you must have had TensorFlow. What is it called? TensorFlow.org. Is it org or something? Yes, it's org. Okay. TensorFlow. You can go to this TensorFlow. It is basically some kind of a framework, on which it is all those computer vision, deep learning model. You can run. There are another important is PyTorch. So TensorFlow is by Google, and then you see this all kinds of funny things is doing. You can go here also if you want to learn. There's so much here to learn how TensorFlow work, library. There's a JavaScript and all. But I wouldn't go here and learn if I'm brand new, because this is for little advanced people who understand this thing. There could be some basically some beginner this thing also, resources also. It wouldn't mind, to check, but it has all the resources it had. So TensorFlow is nothing but consists of hundreds of thousands of libraries, all written in Python, and those libraries are basically is a libraries and extensions. We are going to use it to create those kernel, to create those, pooling, max pooling, this, that, all done programmatically. But you can do it manually. But the problem is manually, right? Instead of writing like one line code with TensorFlow, probably every line of every code, piece of code will be like a 200 lines on Python. That too also buggy. So because of that, all those programs had been combined and created into library. You just pull that library, and that library will do everything for you. So TensorFlow PyTorch is full of library. I'm going to explain what each library does, and what is, and it will be very cool. So let's go there. So you see this, import TensorFlow as TF. You have to name it because some kind of a class. And if you know object oriented programming, when you bring a class in Python and every object oriented programming, that class you have to give it a name as or something, so that that class is represented. So we are importing TensorFlow as TF because we chose a TensorFlow this thing image. In other also you have to do so many things. And then from Keras, pre-processing image, import image data generator. There's another place. So TensorFlow has also another cousin, basically, and that is called Keras. What it does, it converts all the image into some kind of a number or something like that, which I say it's a Keras.io. I don't know. I forgot. Yeah, I think I have. Yes, I remember. You see this Keras? So Keras has all it is also another framework, and it does it, it's like it convert all your, you see this TensorFlow, Keras, all your TensorFlow and Keras, it convert into number and all these things. So this is what the library, this is another library. So basically, and it has all the guides here. You can see the function, API, and all those things, high parameter tuning, all those advanced stuff. Don't worry. Okay, I don't need to teach you all those things on today. So we are getting, and then import image generator. There is from Keras data frame we are importing. That means we are bringing a library called image data generator. What it does, it takes that image and then convert it into those kind of numbers where from where you pull it. So if everybody open, is this open? Then we can go ahead. Okay. Jupyter notebook, not Juniper. Jupyter notebook for tensor. Yes. Those, I mean, this it will take a little time, but I'm going to show you again. If you cannot do it with me, then don't worry, it's there. And you can send me an email also. I'll send you all the link, and you can run it here also. By the way, uh, what I call Padma, we should arrange some detailed training for all those things, because this is I don't know. You have to talk to me about that. Anyway, so we imported it, and this is called cell. So every piece of code you have to run within a Jupyter notebook within a cell. So how you run it? There is two way. You see, there's a play button, and if you put a play button, it will run. But that's like a childish stuff. What you do is it's a shift and enter. And when I shift and enter, that means it's imported the TensorFlow and it imported the kernel. Everything is there behind the scene. You don't know. And then you want to see what is the TensorFlow version it really did it. So it's a TA dot, and this is double underscore. If you have done Python, then it's called Dundee. Okay, I love this word, Dundee. So there's a Dundee here, Dundee there, double underscore nothing. Okay, and then version, and then it will give me the version. This is 2.6.2, the version. So that means everything is downloaded. This version is downloaded. Pretty cool, right? Now it says what? Image data generator. Now we are using an image data generator library to take that image. To train data, because we have a training set and test set, train data equal to train data means we are creating some kind of object here, train data in computer terminology, some kind of a variable where we are saying image data generator replace. You remember every pixel has a value from 1 to 253, 255, and if we convert that into some kind of a 0 on 1, so you just divide by 1 divided by 255. So whatever the value is, the 1 divided by value to 255 by 255 equal to 1. The last one, and the first one is whatever. So anywhere between 1 and 255 will be the pixel characteristics. That's the why we are converting into 0 and 1. Pretty simple, very easy. Then shear range, zoom range, horizontal flip. This, now you are asking the picture, because you are looking at the picture, because we are human being, we look at the picture, computer doesn't know. So you have to show the computer the picture in a different way. So you have to zoom it, show it, you have to flip it. So this kind of a thing it does, and it has a Keras has a library for that also. You come here. Customize data augmentation. Wait, somewhere. You have to find it somewhere. Come on, man, I cannot find it. Append serialization, saving, writing, callback, processing. I don't know, somewhere here. I'll find it because but you'll find it. Those libraries are here. So you see this. So you can really twisting a picture, showing it to a computer different way, and then it taking all those max pooling. You remember from different angle, different this thing, and it goes so that it gives you that. And then a training set. You're creating a variable where train set data is where is our data? Workshop data. Under the workshop data, there's a train. So you have to change it because this is my old program. So you have to. This is a part to the training set. What is my part to the training set? There's a directory called workshop data. Under the directory workshop data is the training set. So we replace with call. And if you don't do it, it will throw some this thing because you say, well, file not found kind of error. So we are picking up the data now. Target size, you remember, every pixel has a size like a 64 by 64. That is the image, standard image size. So, JPEG image, like you can have a bigger size, but this is all those images are like a 64 by 64 size. Okay, pixel. And then there's a bash 32 and class mode binary. So you are taking it and you are taking a batch of 32. You can increase the batch, you can decrease the batch, and all those max pooling. You see this, how many, those kind of the convolution you have it, and that's what you size it. And the classify is what is classifies or no. You find out whether this is a dog or no. Yes or no. It's binary. Yes or no kind of a thing. So if you look at it and if you take the training set, put all those things, take the picture from there, put it in a training set, and then you are using an image generator, and then image generator, what it does it takes the file, all the files.
Hello.
Yes, yes. Everybody left or something?
No, Amit, I think there have someone has some problem. They're not. They said they can't edit the file path.
It's too late because I'll get late if I help them. But just understand the concept. While I'll send you, I'll email it to you. Don't worry. Then understand the concept what I'm doing. This is so, and then we have a class mode binary. So if we this thing, so what happened is all those pictures in the training set, there are 8,000 of them, is converted into some kind of a 0 and 1. That is the part. This is what we are basically, and then we are basically with the help of this image generator, and also doing that's nothing. All those dog and cats picture, now we are converting into 0 and 1. That's the concept. If you this thing, oh my god, what I did, file process. Oh, I know. I see. You see this? I made a mistake. It's not underscore. It's dash. File not found error. Give. See? Again, what happened? Workshop training set. File not. Oh, it's all. I'm already in that directory. I don't need to give the another part. Just training set will be fine. I'm already in that directory. Come on. Such file or directory. Just a second. Let's second. I'll just fix it in a moment. Hmm. Uh, okay. No. Workshop data. Yeah, workshop. Okay, let's do one thing. Let's do one thing. I'll just find it in a way. CR range. Okay. There's some problem here, but I'll fix it later. It was working. I don't know. Oh, yes. File not found error actually. So you see this? There 8,000 picture it pulled and found 800 picture, and there are two class because there are dogs class and cat class. Okay, now you are going to build a model, and you remember we showed this picture of a model. So what we are doing is here in this picture. Oh my god, where is this? I don't know. I just closed it here. I don't know. Anyway, so that's a sequential model basically. So we are creating a sequential model here. There are all kinds of things. So we are keras. From the keras, we are bringing a model. Model is nothing but a, written a bunch of, it's a paragraph of code, and it's called sequential model, which has that kind of a network. It's already inbuilt. Very easy after that. Then what you do is on the keras, now you are adding a layer, because you have to add more layer and add output. So you see this, we add a layer which is like a filter 32. Filter is like a max pooling. Kernel size is 3, because that many, because you have to have a 3. And then there's a function. This is a mathematical function called activation function, ReLU. And then the input shape is 64 by 64 into 3, because you remember standard picture is a 64 pixel into 64 pixel, but that's for the black and white. But we have a color, right? That's called 3 channel. Okay, red, blue, red, green, and blue. And that's what we add 3 channel. So basically, it's going to create a convolutional layer of 3 layer with 64 by 64 pixel, and that's what is defining. You saw that. So you do this, and then we are adding another layer in between. So we are basically running it, and then he said we are running the everything converted into 2D layer. We're adding a 2-dimensional layer, and then we are doing it, and then everything, then we are flattening it. That means we are just, so you have the, remember that, so everything converted into zero and array, and now we have to flatten it and make it one line. That's it. So that's what we did. And then we are inside a dense layer. When you after the input layer, you have to create some dense layer. We are creating it. We are creating it. And then we are now training. So now the computer understood everything, got the training set, converted into 0 and 1, converted into the number, and then we use the mathematical formula called ReLU, rectifier linear unit, activation function. Nothing but this is a function, and you call that function. That function is nothing but a mathematical function. So it is, you design it, and then you flatten it. Everything is done. Now we have to train it. How will you train it? Epoch means it will go the data, scan it, scan all the picture, understand the problem pattern, and you tell them 25. The more, if it doesn't mean if you do it 25 times, because if you are asking the computer to do this once, it may not learn the pattern, but if it is doing it 24 times, it may learn the pattern. That doesn't mean if you increase it to 100 times, it learn better. No, there is always an optimum, some kind of a thing. On a standard is 24 epoch is okay. So it's learning. You see this thing. Oh my God, what happened? Oh, okay, what I did. Training said name test. Okay, there is something problem. CNN feed training set validate test set epoch. Test set is not defined. Why we have done? Yeah. Oh. Oh, again, there's a file not found error here. Okay, so there's a issue here. Don't worry. This is done. Oh, I didn't. There's a file not found error. I didn't do this. So we are going this. Now it started training. Now you said it started training. So it's going to do that epoch. And once you do that epoch, that means it's going to all those things. And then, it will go for 24 round. You see this? And it's going all the picture. It's taking it in max pulling it. It's putting all the formulas there. It's learning the pattern, the combination of 0 and 1. It's learning the pattern. You see the loss, loss function means what is predicted and what is the actual value. It's trying to do that. And then once it is do that, it's one, you will see this. This is like a it will say 1 out of 25 or something. So it will go on for looking at the 25 like that. Okay, so this will take about 3-4 minutes, probably a little more, depends on and then it's a epoch, it's 1 of 25. So this will do 25 times. Okay, so each epoch it takes about 10 minutes. Okay, so that's about it. So and then once it is done, and then if we show a picture and it will say dog or picture, the picture row is here single prediction, and it says it. Oh, it will say again the find not find error. So I'll have to take this out. Okay, so cat or dog, and every picture has a name. So it said, okay, go and scan this picture and then tell me whether, because the machine already learned it, and it go and take the pattern from this picture and compare all the pattern it learned out of this 25 epoch, and then it finds, okay, it's a cat or dog. It's this 2 epoch completed, 2 out of 25, like that. It will go for 25 times, and then it will learn. When it is learned, that means the computer already has eyes. Okay, it learned it, it has a vision now. Now you show it only the cat or dog picture, but it will only, the problem is it can only tell whether it's a cat or dog. It cannot tell whether, if you show a cat and then if you show a donkey, it cannot say that it's cat and donkey. Okay, so that's the way. But it can take any picture and say what it is. Okay, so that becomes very complex, and that's why it's called deep learning. So let it go on, and then once you do it, and if you run it, you will show it cat and dog. I wish I could show it to you if you wait. If you don't want to wait, that concludes our lecture. I'll just show another two three things. I wanted to show you the data pipeline and all, but it's too late. So all those training you model you develop, once you develop the model, and then you have to really deploy it into production. So you create an online feature store, you develop the model, you create a data pipeline, you retain the model, you have the continuous integration, continuous deployment, the continuous training kind of a pipeline. You deploy it. Once you deploy it, you can monitor how it is, and then you can schedule it. All the model will be put in a registry called model registry. Amazon has its own registry, but you can also put it in a GitHub and some other registry. Doesn't matter, it's your choice. But so this is a whole process. So process data, develop model, deploy, and monitor. This is the whole gamut of model deployment, data processing, and all kinds of AI ML job. I told you digital agent. So this each and every feature, a combination of model, will become your digital agent. Once you have the hundreds of digital agent, then you can the first one I showed you, this one. I think this should be the last slide I should show you. Uh, so I'll just come back to this slides. A lot of dense stuff. I mean, it's very. I don't know. I should have taken a easier stuff. Okay, actually, other places I lecture, they're little advanced in that. In this thing means they already are knowledgeable. So and then you see this, and so this is the digital. So you see all those diagram I showed you, that becomes one particular portion or function, and you can create all those several models. You can create a pipeline, it becomes a digital agent, and that digital agent you can combine globally. Once you combine globally, you have the one solid strategy, and then you have the full digital network of artificial intelligence, your data strategy, this that. So this is what we can really go and show it to our customer, that this is what we can build for you. We can build this kind of a team for you. We have the expertise. We can. So that is something I'm really looking at this time. And if you wait, it's done 5 of 25. So it will take another 5-7 minutes. If you want to wait, I can show you the result. Otherwise, I conclude my lecture. Padma. Hello.
Yes, yes, Amit, I'm there. I'm just waiting for people's remarks. That's all. Because it's not.
Was it little hard for everybody? I don't know. What do you think?
Curtis and, you know,
Hmm?
I gave you guys option to talk if you want to, you can unmute yourself.
No,
Yeah.
I
I think Curtis says that he has issues following the last part. I think
yeah. See,
what
last I tell you this. I mean, the CNN convolutional neural network is a very complex, very complex stuff. And last part, to be honest with you, I didn't do a good job. The reason is I just wanted to just wrap it up within 4 or 5 minutes. The last part itself is at least 2 hours lecture, and I apologize for that. I mean, because I didn't know the audience would be like they have never done it, or most of my audience like knowledgeable people, which I lecture at Google, Amazon, they already do it. So I just wanted to, but anyway, that's it's not like their fault, it's my fault to make such assumption. So, and because of the time, because it's already 3 or half an hour, more than the scheduled time. So I just wanted to wrap it up, but that's about it. So if you want to wait for 4 or 5 minutes, I can go over and again show that. But that's a totally new. So the things you take it from here is how the convolutional neural network works. The past 4 or 5 slides I did. So basically, every picture, because you are showing your computer eyes, but doesn't mean it has to be eyes. Okay, it can be also that natural language processing, which is also a part of the deep learning network. Also, that same convey. So here, every picture, but in other words, you can read every instead of looking at a picture and recognizing whether it's a dog or cat. For NLP, you can read every word, and then every word will represent a meaning, and then you feed it and you train it, and it's a billions of times you do it, and the computer, the program learns a pattern. Oh, dog means dog, cat means cat, amit. Oh, this could be a name of a person, like that it can recognize. So you can have the millions of this combination called an NLP. So you can also use that. But on the picture, here what we said is, understand this, every picture is nothing but it on the screen, it represent a combination of different shades of a pixel. So every picture is a tiny 64 by 64, as I said, a standard picture we used it, pixel. So 64 length, 64 breadth is some kind of square size picture, but at the same time it's a colored picture, as I said, red, green and blue. So it has a 3 channel, and then every picture represented a number from 0 to 255. So 0 to 255 is the different shades of the picture. So a pixel. So now you combine that, and you combine that with the red, blue, and green. So that represent a whole picture. Now out of that, which is really, and that's called picture engineering. Basically, how many of them are really relevant to understand what is that pattern. If you want to know the eyes of a dog or the ear of a dog, I don't need to know everything about that. We just need the outer layer pattern, and we max pull it. So every picture is broken into tiny different features. Those tiny different features is converted into some kind of, as I said, we have the image generator and all. It is converted into 0 and 1, nothing but number is flatten it. And those number, once you have the number, every pattern, every picture has a pattern of numbers, and those numbers mathematically we can learn. So when there's a year of a dog, and that represent a certain combination of this thing and numbers, those certain combination number, if we see the 10,000 year of a dog, we can really, every dog will have a different pattern, but computer will through that pattern mathematically will learn, oh, this combination of number must be a year of a dog. This combination of number is must be a nose of a dog. Like that, when they combine and everything done, that is what the last part of it, and that is called sequential. It builds a model, and then once you model the model, it learns it. So it learns the pattern of a picture, and then when it looks at the 10,000 picture, it finds a common ground. Oh, this kind of a pattern, because it has already looked at 10,000 picture, it already found this kind of a picture has to be a dog, it cannot be cat. And then when you show a new picture, the new picture pattern is read programmatically, and then it compares with what is learned, and then it gives the prediction. Make sense?
Yeah. Yes.
Okay, so that is what, if you get this, it's this how many, so it's doing, still doing like a, it's 11, so there's something, if you want to wait, do that. So this is what you flatten it, you see the last part. After that, you added a dense layer, we are using a dense layer, and this is a different layer because, as I said, you saw this thing, and every layer represents some kind of a pattern basically. And then your output layer, which is you see it, output layer, and the input layer is the press, this thing, it knows all the pattern. When it comes to the new layer, it says, it find the difference between output layer and input layer. Okay, and then it finds the loss. I'll give you an example of loss. I'll give you an example of say, you know just a scale, ordinary scale, old days, I don't know, here you'll find, but in India still find, people put weight one side and another side, they put, like a, if they are, with an ordinary scale, you are using to say weight, some fish. So you put the fish one side, and you put, some 1 kilo, some kind of weight on the right hand side, and you scale it, and you see this, if the piece is heavy, it will go down. You said no, it's more, must be more than 1 kilo. So you should put another 100 gram of it. It goes further down. That means, oh, it's a heavier than, lighter than 1 kilo, but heavier than 1100 grams. So something in between. And then you put, instead of taking that 1 kilo, 100 gram out, and put a 50 gram this thing weight. So you just combine it, and then finally you arrive at a point, the fish weight 1.34 kilo or kg. So that what you are doing is, you have a, you just use the trial and error to find the loss. How much loss? That means you have a value y, which is on the left hand side. You have a value y bar, which is on the right hand side, and right hand side value of the y bar is 1100. It goes down. You see this? So there is a negative loss. That means y minus 1100 is a minus 100. Oh no, no, this is something heavier. Then you take that out. You put a 50 gram weight, and like that you do a trial and error, and then you, after 2 3 times or 4 times, depending on how accurate you are, you find the loss, you minimize the loss, where the piece weighs 1050, and the weight you put on the right hand side 1050. That means it's balance it. That means loss is minimum, loss is zero. Make sense? So
Yes. Yeah.
similarly here all the pixel numbers, you compare with the outer layer, and then you see the pattern, you compare the pattern. So y is your input layer, all the pattern, and y hat is the output layer, and you combine it, and you minimize the loss. As you minimize the loss, and it will see it here also, it is showing, you will come to a point where both will merge, and it will become zero. The idea is to minimize the loss. It may, on a computer, this kind of thing, it will never become a zero, but you see this loss is, minimizing. You see this 3.30. You see this is loss is
Yeah.
3. If you see it, it's showing how much is the loss. As the loss is minimizing, you see this accuracy is increasing.
Right.
Okay. You see this, as his loss is 8.27 accuracy. Sometimes his accuracy increasing, decreasing, but it's like giving a trial and error. and after 25 epoch, it's already done 15 epoch. So it is pretty much is reaching an accuracy of 0.84. So that's a pretty, that means your accuracy or your loss is also minimizing. Is it 3.5 to 3.562 to 0.3528? The next one will be little down. As the loss is minimizing, your accuracy is increasing. This is nothing but your, so the best way to learn is it converting into some kind of image into numbers, and then with the mathematical equation, you are, those number is checked with the number of your test data, which is another set of picture, and then it is combining and seeing what happening. And if it is says no, this the pattern it is learning, and then it's also testing with the test data and seeing whether it is matching or not. If it is not matching, that means loss it is not minimizing. As the loss, again it goes and run, and again it changes the weight, just like a weight. Here also it's called weight, by the way. So it's like instead of 100 gram extra, you put 50 gram, so 1 kilo weight plus 50 gram weight. So now you see how much is the loss. Like that, you arrive at a point. So here also it's called weight. So
Amit,
you increase the pixel density or number with some kind of arbitrary weight, and then you calculate with the weight, and there's a mathematical formula, and then finally you arrive at a point that your loss is minimum. May not be zero, but it will be very negligent. Then you said, oh, it's getting into accuracy. Then you show a new picture because the computer already learned it. This is the pattern, and if it says that pattern is pretty much similar to the pattern it learned, it gives the prediction.
okay, Amit, I think this 45 minutes, so I think maybe
Okay,
we
that's
should
it. I just
conclude.
wanted to say, because this is the last this thing. Yeah, I would say this is Padma. I would like to talk to you about that. I don't know, but I'm trying to start a some kind of a day fest. It's like a month long, every Saturday, Sunday, and the people can really learn and do things, and they don't care about time and all. That's what the day fest was. A lot of people benefited from that. Or if you want to do some corporate training, we can come out to.
Yeah, yeah. Why don't you and I talk directly? Give me your number. I'll call.
Yeah,
Um,
you have my number, right?
but do you mind giving it to me one more time?
Yeah, you want me to give it to you or now, or you want me to just send it to you?
Yeah, please send it to me. I'll call.
I think I already sent to this lady Savani. She has that.
Yeah,
Look
maybe
at
I'll
that
take it.
email. Look at that email. I mark a copy to you also. I said, if you want to call me, please call. I give the phone number.
Okay. Okay, I'll take it from her and I'll call
Look
you
at
and
my
then stop.
last email. Yes. So, I mean, I tried my best, but, these are all complex stuff.
Yeah.
These are hands on. Actually, if I don't do the hands on, I could have wrapped it up even before 2:30 if I have to show only the slides. But slides is slides.
Mhm.
Okay. Thank you very
Okay.
much.
Thank you,
So did
everyone,
you did
for
you get
coming.
any feedback, anything? I don't know. People may or may not like it. I don't know. Depends on how
I
they.
the Sharvani, I'll ask Sharvani and I'll send it to you and let's both talk. Okay. I'll call
Okay.
you.
Okay.
Okay.
Thank you. Thanks a lot.
Thank you. Thank you, everyone. Thanks.
Okay. Bye.
Bye.